In today's lab, we'll be using a process known as electrolysis to take water, run an electric current through it, to convert it into its two natural elements. This is the reaction that's going to occur at the cathode, seen here, which is negative in electrolysis. And at the anode, which is positive in electrolysis, it is reversed. Now, to get electric current to run through the water, we need to add an electrolyte. Both ions will facilitate the passage of the current through the water and make this reaction work. For this lab, we're going to need a diluted solution of H2SO4. We're going to do that by taking 200 milliliters of water and getting this graduated cylinder and adding 10 milliliters of concentrated sulfuric acid H2SO4. And then we're going to add it to here and thus diluting it. Alright, now we're about to pour the sulfuric acid into the water. Remember to do this in the fume hood so that the fumes don't get you like this. Remember not to add water to acid because it's a very exothermic reaction. I get it. Hey, what are you doing? We're pouring the H2SO4 solution in the burette. The burette tip should always be closed to avoid accidental spill. Now we add the copper wire. And now, okay, now we'll be connecting the system together. So first we're gonna connect the gray wire. If you have any questions, you should refer to the diagram given on your lab sheet. Connect gray wire to the negative charge circuit in the ammeter, and then the other end of the gray wire will be going to the 0.5 circuit, 0.5 to 40 circuit. Connect this, the alligator clip, to the copper wire. Make sure you get the copper and not the rubber. And we will insert the other end of the copper wire into the system. Plug it into the positive side of the 0.5. And lastly, we'll be taking the last wire, connect the alligator plug to the copper wire that we stuck to the burette. Now this end, we'll be putting into the plug on the ammeter where it says 1. There you have it. That's your system. Alright, so now we're going to proceed with the actual electrolysis. What you want to do first is, since you lost a considerable amount of water when inverting it just because of gravity, you're going to measure the level of water, or dilute solution of H2SO4, I should say. Remember to account for the meniscus. So I'll be timing the experiment, and Yuri will be timing when to start and stop my recording. So, should we start? Yes. All right. 3, 2, 1. Let's see bubbles start to form. Mr. Junho, press the start button to be able to. Still going. All right. Run it for as long as you like. You're gonna have 2 trials anyway. I'm gonna say 3, 2, 1, and at the end you're gonna stop the timer. Ready? 3, 2, 1, stop. That was surprising because we stopped at exactly 2 minutes flat. That's precision. That is precision.
Alright, here are the results. Here we have the initial liquid level, which you measure before you do the experiment. And here we have the final liquid level, which we measure after we do the experiment. Alright, yes, this is going well so far. Here we have the volume of H2 collected, and it's the final from the initial liquid level, right? Alright, now, I don't know how. Okay, I'm stuttering, but here we have the current, and you measured that during the experiment. We have the time that we ran the timer for, so this is how long the experiment took. We have the temperature, and that's our temperature given. You find it during the lab. Here we have the atmospheric pressure, and you either look it up or are given it. Here we have the pressure of H2O at that temperature, and you look this up by plugging your given temperature into the internet. Here we have the pressure of H2 at that temperature, which we find by subtracting the pressure of H2O from, at that temperature from the atmospheric pressure, giving the only remaining pressure of H2. 1, 2. Yo, 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 I'm an AP chemistry rapper. I split you like a system, and my rhymes are so good, you would swear that you missed them. I split you into your individual elements. Cause I am electrolysis. Represent! Word!